Hey there, Keys Precalculus. I am going to go over a problem from the exercises for section 3.5 in your book. We're going to do problem number 16 on page 224. But before we do this, I just want to remind you that we're just looking at the logarithmic and exponential models. We're doing application of the various models. I really want you to study example 3, 5, and 6 carefully before you do your homework, and look at example 4 as well. It's just a graphing example, but I want you to read it for understanding. So study those examples. I don't need to go over them with you because they're very clear in the book, and that should help you with your homework. But I do want to do a problem similar to number 15. We're going to do number 16. So if you look on page 224, it's a compound interest problem. And remember, I told you the exponential models work very well in finance. Okay, so we're going to look at this one. It says compound interest. Complete the table for the time t necessary for p dollars to triple if interest compounded is compounded annually at a rate r. Create a scatter plot of the data. So over here on the right of the screen, I wrote up our two compound interest formulas that we are using in this class. The first one is for when your interest is compounded at a finite number of times a year. That would be n times a year. Like monthly, n would be 12, daily n would be 365, weekly n would be 52, and so forth. But there's also the compound interest formula for continuous compounding, and that is the second formula. A equals principal times e raised to the rate times time. You would use that if the interest was compounded continuously. Now in problem 16, it says is compounded annually. So which formula are we going to use? You're right, we're going to use the top one up here. We're going to use this first one. Well, I'm trying to draw a star. It's not working. Okay, anyway, let's come over here and I'll rewrite the formula. A equals the amount in the bank equals the principal times 1 plus the rate divided by the number of times it's compounded a year times the number of times it's compounded a year times the number of years, or the time. Now it says how long will it take for our principal to triple. So what is our independent variable and what is our dependent variable? In this case, our independent variable is the rate. It's r because we want to know how long it will take for our principal to triple at each different rate. So what we don't know is how long it's going to take. That's going to depend on what the rate is. So our independent variable is the rate. Our dependent variable in this case is time. Okay, so r is our x, t is our y. P is our principal. It doesn't tell us how much we invested. We just want to know how long it's going to take us to triple our investment. And then, of course, n, it says it's annual. That means it's one time a year. So n will be 1. R, we're going to plug it in every time to figure out what t is. Okay, so let's rewrite our equation. I want to know how long it's going to take to triple the principal, so that my amount will be 3 times whatever the principal is. Equals principal. It doesn't matter how much I put in. I just want to know how long it takes to triple it. Times 1 plus r over n, which in this case, r over n is just going to be r. So 1 plus r raised to the number of times it's compounded a year, which is 1 to the t. So here is our equation. Now let's simplify it and see if we can get t on a side by itself. So the first thing I'm going to do is I'm going to divide both sides by p. Get rid of that. And what happens with that is the p just disappears because it doesn't matter what the principal is. Okay? So 3 equals 1 plus r raised to the t. Now again, I'm trying to solve for t. And it's a variable in the exponent. I can't take the tth root of something. So I'm going to need to not exponentiate, since you haven't even take the logarithm of this. And I have to take a log of the same base that is raised to the t. So this that I'm putting in a box is going to be my base. That's unusual, but that's what it is. So what I'm going to do here is I'm going to take log base 1 plus r of 3 equals log base 1 plus r of 1 plus r raised to the t. And by the logarithmic inverse property, these are going to cancel each other out, and basically I'm going to have t equals log base 1 plus r of 3. I'm going to plug in all these numbers over here on this little XY chart, or the RT chart, for r, and fill it in, and then graph them on a scatter plot. So how do I do that? Well, first of all, I'm going to convert these to decimals. So this would be 0.02, this would be 0.04, this would be 0.06, 800ths, 0.1, and 0.12. So those are the numbers I'm going to use for r. And I'm going to use my calculator, I have to solve for t. If you have the TI-84, it's very simple. If you don't have the TI-84, from what I understand from those of you that have the 83, you're going to have to use the change of base formula 6 times to solve this problem. So if you have the TI-84, to figure out your t for each one of these r's, you're going to hit the key that says math, and then right after that you're going to hit the key that says alpha, and then you're going to hit the key that says math again. And when you do that, you're going to end up having something that looks like this, what I'm underlining on your calculator. You're going to have two little boxes and that I've highlighted in yellow. You're going to fill in the bottom box. That's going to be your base, and your base is going to be 1 plus whatever r is. So you don't have to figure out, you don't have to write the word plus. You can figure out 1 plus 0.02 is 1.02. So that's what you would put in the first time. And then you're going to hit the right arrow, and then you're going to hit 3, because you're taking the log base 1 plus r of 3. So this will be a 3 right here. And then you're going to hit enter. And whatever you get, or whatever numbers you punched in, like if you punched in the 1.02 the first time, and then the 3, and hit enter, you're going to end up getting something, this number right here, rounded. It's 55.48. Okay? And so you go ahead and do that for 4%, 6%, 8%, and 10%, and then compare your answers. While you're doing that, I'm going to explain what to do on the TI-83. Okay, so if your calculator does not automatically do change of base, you're going to have to put it in. So I put the change of base formula up here, which is log your old base of some number equals log your new base of that number divided by log your new base of your old base. Okay, y'all done plenty of problems like this, so you should remember it. So what we're going to do here is we are going to, for example, for the first one, we want to take the log base 1.02 of 3 to see what it equals. So in your calculator, you're going to type the log key, and then the 3 key, and then the close parentheses key, divided by log, and then in this case, for the first, you would type in a 1.02. Of course, the second one you'd be 1.04, third one would be 1.06 or whatever, and then enter. And when you do all of that, you should get the same answer. You should get 55.47818, which rounds to 55.48. Okay? So if you have the TI-84, you can hit math alpha math and then fill in the blanks. If you don't, you have to hit log 3, close parentheses, divided by log 1 point whatever, and then enter. And in that case, you're going to fill out your chart, and y'all go ahead and do that, and then come back and check your answers against mine. Okay, check your answers against mine, and you will see that as the interest rate goes up, the time in years goes down. At 2%, it'll take you 55 years to triple your principal. But at 12%, it'll only take you almost 10 years to triple your principal. Okay? If you were, and then of course, as I say, to fill it out on a scatter plot a scatter chart, or a scatter, whatever it is. I can't word right now. But anyway, you're going to fill it out on a graph with just points, and you'll see that it is, or rather, it appears to be a decay model. It's a logarithmic model that decreases. in time as your rate grows. I hope this helps a little bit with your homework. You are going to have to think about these problems and figure out how to apply. We will go over questions on Tuesday in class, but hopefully this assignment will be a fun challenge for you. I hope you'll have a great weekend.